Hey scholars, thanks for joining me today. I'm Mr. T, and today we're going over Module 1, Lesson 11, which says we can use place value understanding to fluently add multi-digit whole numbers using the standard addition algorithm and apply the algorithm to solve word problems using tape diagrams. Okay? So the first thing we want to do is look at our new vocabulary words. Our new vocabulary words are add-in, and add-in is a number that is added to another. So if you look at this equation, 6 plus 4, you would see that 6 and 4 are add-ins. We need to bring them together to give us the total. So when we have numbers that we bring together, those are called add-ins. Okay. We also have the word equation. An equation is a sentence that contains an equal sign showing that two expressions are equal. We also have algorithm. An algorithm is a step-by-step procedure to solve a particular type of problem. And you can see that this is what our standard algorithm will look like for addition. It's things that you've probably seen before, but with smaller numbers, right? And then a tape diagram is a picture or a drawing that represents a particular problem. And typically what we've seen that in the past is that a tape diagram is a large rectangle. It is cut into 2, 3, maybe 4 pieces, and our whole is sitting up top. So this is what a tape diagram you've probably seen before, right? So let's go ahead and jump into the meat and potatoes of our lesson and look at how do we add using place value disk and a place value chart, okay? So the first thing we're doing is looking at this problem of 3,134 plus 2,493. So the first thing we want to do and recognize are what are the two parts of our that make up the whole? Well, the two parts that make up the whole is 3,134 and 2,493. These are my add-ins, right? So what we would do is we would draw a rectangle. Because I have two parts or two add-ins, I'm going to break that rectangle up into two equal parts. And then I'm going to write in 3,134 and then 2,493. So now what I want you to think about is what is the unknown? What's missing? Well, what's missing is the whole or the total. And our whole and total go up top. And because we don't know what the whole or total is, what number that is, we can put a letter. And I'm going to go ahead and put the letter A. So when we label an unknown quantity with a letter, we call that a variable. So we can use a letter to represent an unknown number, and when we do that, it is called a variable. Okay? So let's go into solving this problem. So the first thing I want to do is I want to draw a place value chart from ones to thousands. What I'd like you to do is pause this video to draw your place value chart. Once you have your place value chart, come on back. Thanks for coming back. So hopefully you have your place value chart starting at your ones place, your tens place, your hundreds place, and then your thousands place. And again, I'm going to use my abbreviations to represent those place values. Now that we have my place value chart, the first thing we want to do is represent the first part or the first add-in in dots, right? So I'm going to represent 3,134 in dots. So what that tells me to do is go and put 4 dots in my ones place to represent the 4 ones, 3 dots in the tens to represent 3 tens, 1 dot in the hundreds to represent 100, and then 3 dots in the thousands place to represent the 3,000. Okay. Now that we've done that, we need to show and because we're adding, we're going to show the second part or the second add-in in the same place value chart. So what that means is I'm going to go and show 3 dots in my ones place to represent the 3 ones in my second add-in. I go to my tens place and draw 9 dots. And I'm going to use a 5 frame to kind of help me with that. I go to my hundreds place and draw 4. And then I go to my thousands place and draw 2. Okay, now that we have this done, we can simply go and solve this problem. Okay, So we look at our ones place first. We always look at our ones place when we're adding, and we say 4 ones plus 3 ones equals how many ones? So if I counted the number of dots in my ones place, I recognize I get 7 ones. I go to my tens place. I see 3 tens plus 9 tens is 12 tens. But 12 tens is not allowed to be written in my place value chart because we're able to bundle and make a larger unit. So 12 tens can make what larger unit? Well, it can make 100. So I need to bundle 10 tens together, and I bundled that 10 tens together to give me 100. So how many tens did we have left over? Well, we had 2 tens left over. So I would put a 2 down in the tens place, not 12. I now go to my hundreds place. I have 100 plus 400 is 500, plus one more 100 that we got from the tens place. That's 600, so I put a 6 down in the hundreds place. I move to my thousands place and say 3,000 plus 2,000 is 5,000. So my sum, or my total, or my whole is 5,627. So 3,134 plus 2,493 gives me a whole of 5,627. And what I want to do to make my answer complete is make sure that I write my answer next to my variable with an equal sign, so that way we know that my variable, or the unknown number, is 5,627. Okay, and that's how you would solve an addition problem using place value dis and a place value chart. Okay, so let's go ahead and jump to a new problem using the same method, but this time we're going to add in the standard algorithm, right? So what does that mean? The first thing we need to do is figure out what are the parts of my whole. Well, the parts of my whole is 40,762 and 30,473. So I draw a tape diagram to represent that. Okay, so I'd go ahead and do that on your paper. Okay, and so now what I want you to do is pause this video and tell me, what is the unknown? What's missing? Once you have your answer, come on back. Thanks for coming back, and thanks for coming up with your answer of the whole, or the total is unknown. And seeing that we don't know what that total is, or what that number is, we need to use a variable, which is a letter that represents the unknown. And this time I'm just going to use the letter B. Okay? So now you got it. Place value chart. So pause this video to draw your place value chart. This time I would recommend having a place value chart with 6 place values, just in case. Okay, so once you have that drawn, push play, come on back. Thanks for having your place value chart down. So let me go ahead and model my place value chart. So again, I have my ones place, my tens place, my hundreds place, my thousands place, 10,000s place, 100,000s place. And again, my place value chart is a little bit too small. I should have made it a little bit bigger so we had enough space for everything, okay? So now that we've drawn our place value chart, what part should we put in our place value chart first? So what add-in should we put in first? Okay, well, we should just put the larger one in, and the larger one is 40,762. So that shows me I put 2 in the ones, 6 in my tens, 7 in my hundreds, none in my thousands, and then 4 in my 10,000s, right? Okay. Now that we've done that, I want you to tell me, what is the next thing we should do? Once you have your answer, come on back and we'll go through it together. So great. Welcome back, guys. Thanks for joining me again. And hopefully you said we need to show our second add-in, or a second part in the place value chart. So we need to put 3 dots in the ones, 7 dots in our tens place, 4 dots in the ones, none in the thousands, and 3 in the 10,000s. Okay. And what I'm now going to do is I'm going to show you how to do this in standard algorithm. So what that looks like is putting our addends on top of each other to add together. Okay. But we can use our place value chart to help us solve the standard algorithm. So look at this. 2 ones plus 3 ones. If we just counted the ones, we'd recognize that is 5. So we just go ahead and put 5 in our ones place in our answer, right? So now we move to our tens and we see that we have 6 tens plus 7 tens. Well, if I counted the number of dots, that tells me I have 13 tens. And so again, we want to say, oh, well, we can't do that. So if we have 13 tens, what needs to happen? What I'd like you to do is pause this video and tell me what happens to those 13 tens. Once you have your answer, come on back. So welcome back, guys. So hopefully you said that we need to bundle 10 tens to make 100. So let's go ahead and bundle 10 tens to make 100. And when I do that, I move this 1 over to make 100, right? So notice what's going to happen in my standard algorithm. What that tells me to do is I'm going to put a 1 in my hundreds place, and then look how many tens are left. We have 3, so we still have 13, but the 1 is now moved over to the hundreds place, and that 3 can go in our tens place, right? So we get 3 tens left. So now let's look at our hundreds. So we have 700 plus 400 plus 100 is 12 hundreds. So again, we run into the same problem where we need to bundle and move. So how many hundreds do I need to circle to make 1,000? Well, it's 10. So let's go ahead and bundle 10 together. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So here's 10 hundreds. 10 hundreds make 1,000. So notice I need to go back to my standard algorithm and make 1,000, put that 1,000 on top, and then ask yourself how many hundreds are remaining. We have 1 and we have 2. So that tells me I don't have 12 hundreds anymore. I only have 200, and 2 goes in both the place value chart and our standard algorithm, because that 1, I use 10 hundreds to make 1,000, which is represented right there. Okay. Look at our thousands. We have 1,000, so let's go ahead and put 1 down, and then move to our 10,000s, and we see 4,000 plus 3,000 is 7,000. So I would put that 7 down in my 10,000s place. And what we recognize is that our sum or whole is 71,235. Okay, and I put that right next to my variable. Okay. So again, the difficult part is going to be the standard algorithm and making sure that when we have more than 10 of one unit, that we bundle and move, and we show that bundle and move of in creating a larger unit, and we make sure that we put that 1 on top to represent that. Okay. So hopefully you got the gist of what you're learning today. Your teacher is going to spend a lot more time with you around standard algorithm and how you're going to use that to solve addition problems. But I just wanted to show you some deeper understanding of why the standard addition works. So when you go to class today, I want you to think about how is recording the regrouped number in the next column when using the standard algorithm related to bundling disks. Okay, so think about that question. Have a great time. Thanks for joining me. You did a great job. We'll see you next time.